Have you ever been surprised to see Ukrainian sunflower oil in the supermarket? Well, you shouldn't, because Ukraine is the leading producer of sunflower oil in the world. Also, there is high probability that if you're buying cereal products in your local shop, that they are made of Ukrainian grains, as Ukraine is the seventh largest player in the world crop market. Our team decided to investigate Ukrainian agriculture not just because it's our native country, but rather because it has tremendously high agricultural potential. Just take a look at the facts. Two-thirds of arable area of Ukraine is rich black soil, which is more than a quarter of its world assets. Imagine the area of Great Britain. Well, it's even more. We're exporting agricultural products to more than 190 countries in the world, this being more than 42% of our total exports. Though this statistics is very fascinating, we found some facts that are not that inspiring. For example, 2 million hectares of Ukrainian lands are used inefficiently. This is about the area of such country as Slovenia. Moreover, 5 million hectares of Ukrainian lands are not used at all. Just take a look at the graph. This is Ukrainian performance in agriculture compared to the EU countries. Do you see the big gap? Being one of the biggest exporters of agriculture in Europe, we have one of the lowest yield per hectare. If we catch up with the EU countries, we could double our crop. Now we are in the 6th position in the world in wheat export. With the new technologies, we could make it to the top 3. So we decided to start investigation with looking for the available data sets and for public information. And we found the satellite applications and research in NOAA Star. They provide data on different parameters from the satellites, but the main disadvantage of those is poor resolution, only 4 kilometers per pixel. Going further, our aim was to find some data sets with high resolution, and though we found such, we didn't have access to the data. Those were Sentinel and Planet.com. Not only satellite images are required for the analysis, but also some other information. And when we found Land Parcel Identification System, which is the European system for agricultural monitoring of fields, we realized that we also need field areas, identification of crops grown there, and also their geolocation. LPIS in Czech Republic, for instance, has information for more than 150,000 parcels, but not in Ukraine.
So we decided to look for specific datasets in Ukrainian agricultural field. That's why we applied for a technical networking conference, AgroTalks Day, that was held in Kyiv. There we had a chance to present our ideas and to receive valuable feedback during Q&A session. And what we heard shocked us, because now Ukrainian companies don't use any software to predict harvest. They use only historical data and experts' opinion. From conference we managed to collect data. It was images from drones and also statistical data from 160 fields for 5 years with weekly measures of NDVI. We were very inspired after the conference and make a query to Ukrainian statistics services. Turns out they don't have detailed data, only raw numbers for 2-3 years, and Ukrainian cadastre answered that they won't provide us any data at all. After conference and data review, we decided to focus on crop yield prediction. It is a crucial problem and don't have any good solution yet. This problem is important both for business and for government. Business can increase their profit and government can make a prediction of deficit and act on it in time. Here you can see hypothesis that we postulate. Weather conditions and NDVI are consistent parameters for forecasting the crop yield. NDVI curve allows us to classify culture, and NDVI curve allows us to predict expected yield. I mentioned a couple of times term NDVI, so I'll explain what it is. NDVI stands for Normalized Difference Vegetation Index. And you can see the formula on slide. It depends on reflection of near-infrared light, because we can see significant difference in this spectrum. Many companies base their research on this index because it is easy to get. but it has sensitivity to atmospheric effects, to small clouds and shadows, and to spectral effects. When we started to build the models on pure NDVI, we saw that it is not productive. Here you can see intuitive picture why. This is NDVI measures for 1 year, for one cultivar, and on the left plot it is NDVI for fields with maximum and minimum crop yield, and on the right plot with equal crop yields. You can see the difference between NDVI measures doesn't imply the difference between crop yield.
Our ambitious idea to forecast the harvest using NDVI only was demolished, and you can see the statistical proofs of that on this slide. On the left picture, there is the correlation between NDVI and yields, and as you can see, both Pearson's and Spearman's correlation coefficients are very low, while the p-value is rather high. Also, when we tried to train our model on the data, we obtained R-squared coefficient of determinants equal to 0.05, which is very bad. Then we decided to train our model on the weather conditions as features, and as you can see on the right-hand side, there is also no correlation between weather conditions, say temperature, and yields. Even more, R-squared was negative, which means that we could predict the yields using just the expectation value, and it still could be better. But when we combined both data sets of NDVI and weather conditions, we actually trained our model. Apparently it was random forest regressor, and we obtained the R-squared equal to 0.319, which is not that high, but still take into account that we have very poor small data and less than 200 samples and lots of features. It's rather good result.
So, let's move to our next hypothesis. Considering the data we got from farmers, we were eager to discover possible patterns and templates. First of all, we grouped yearly NDVI values from different parcels by culture type, which you can see on the graphs. Week of the year and NDVI values are plotted on X and Y axis respectively. The curves represent the mean NDVI interpolated continuously and for every week by specific cultures. And you could see there is some general pattern for all cultures by every year. However, there is a visible year-to-year difference. So, we make an assumption that there could be some unobvious dependencies that affects NDVI. Well, we decided to fit our model to that data. This slide demonstrates learning process for fitting curve on different polynomial degree. As you could see, the higher is the degree of polynomial, the better is curve fit. And this is the best polynomial fit of curve for different crops all over the years. So let's see what we can make out of that data. Well, we have a generalized curve for every culture. Assume we also have NDVI for some parcels which also could be represented as a curve. Taking that into consideration, we could say how good they are correlating with each other. In other words, we can find the exact culture based only on NDVI for some parcels. And there is also other application of our model. This slide represents the deviation of the real NDVI from the forecast of our model based on data from previous years. Considering the piece as an example, we see the real values of NDVI are lower than the expected ones, which means that the harvest will be poor. There's also a few other solutions that are already available on the market. It's an application that's allowed to correct weather conditions such as fog, humidity, clouds, and monitors vegetation process to predict yield. Also, we have some private speech with companies that provides field monitoring here in Ukraine, and they told us the following. Big agri-holdings are not interested in field monitoring because the soil efficiency for now is good enough, so there is no reason for farming optimization. This fact gives us the ideas who will be our target clients. Our solution will perfectly fit small and middle-sized farms who apparently are interested in optimization of their farming. To sum up, I'd like to say the following. Our team made deep and full overview of the open data sources that are working with NDVI. We analyzed the wide set of factors that affect the NDVI culture vegetation and thus the yield. We've managed to build both regression and ensemble models that help us evaluate our hypothesis and the most significant features for forecasting. Our solution is scalable and it's possible to apply it on the other regions. We believe that our solution could be game-changing in the sphere of agriculture data analyzing.